Now let's talk about finding the pH of a solution that contains a strong base. Here we're asked to calculate the pH of a solution that has a NaOH concentration of 0.1 molar. We need to start this problem by thinking about what type of a question we're dealing with here. And when we look at NaOH, we recognize that we have a soluble compound that contains the hydroxide ion. If you have a soluble compound that contains the hydroxide ion, you're dealing with a strong base, right? Remember that hydroxide ion is the only strong base that we're going to deal with in this class. And also, it's important to remember that when you have a reaction where one of the reactants is either a strong acid or a strong base, that's a stoichiometry problem. Remember, you're putting all those S sounds together. Strong acid or a strong base means stoichiometry. So let's write out the reaction and set up the stoichiometry for this question. What we have here is NaOH dissociates completely into Na plus and OH minus. And this is a strong base, and so the dissociation is 100% complete. That's why a one-way arrow is being used here. So strong equals stoichiometry. It equals a one-way arrow. All of the NaOH dissociates into Na plus and OH minus. You cannot go back. That's why we don't draw an arrow going in the reverse direction. Now, for stoichiometry problems, we can use the mole ratio. All right, so let's do that here. For the NaOH, we're told that the concentration is 0.1 molar, meaning that we have 0.1 moles of NaOH per liter of solution. We need to convert that into the hydroxide ion, right? Because it's the concentration of hydroxide ion that controls the pOH and, by extension, the pH. So let's convert that to hydroxide ion. It's a 1-to-1 mole ratio, so there's 1 mole of hydroxide ion for every 1 mole of NaOH. Do a little unit cancellation here. Moles of NaOH cancel out, and I'm left with units of moles of hydroxide ion per liter. 0.1 moles of hydroxide ion per liter. Or what you can say is the concentration of hydroxide ion is 0.1 molar. Now that we know the concentration of hydroxide ion, you can use that to find the pOH, because pOH is the negative log of the hydroxide ion concentration. So what you end up getting is that the pOH of this solution is the negative log of 0.1 equals 1. Then it's really important as you're working through these problems to be carefully labeling what variables you're solving for, and to also think about what a reasonable answer would be. So you might get to the end of this problem and think, or you might get to this point in the problem and think that you're finished once you have the pOH. But the question is not asking for the pOH, they're asking for the pH. And so we haven't quite reached the end goal of the problem yet. Additionally, it's beneficial to consider what a reasonable answer would be. Since this is a solution that contains a strong base, we expect there to be a pH value, right, that's greater than 7, because this solution should be basic. So when you get to this point in the problem and you see pOH is equal to 1, you know that you're not finished yet. You know that you have a little more work to do because you don't have a reasonable pH value. The last step that you need to do is to convert the pOH into a pH. So lastly, what you can do is say pH plus pOH equals 14. And so the pH is 14 minus the pOH. Therefore, 14 minus 1 is 13. That is the pH of the solution, and that's an answer that makes sense. That's a pH value that would correspond to a basic solution. This brings us to the end of this video. Next, we'll talk about finding the pH of a solution containing a weak base.